Okay, so today we're going to be talking about plate tectonics. The continental drift. Well, who came up with this thing? Well, it was proposed by Alfred Wegener. So basically, we know this, as you see here, everything was one big old continent, right? So we call that the supercontinent. So his theory said, hey, Pangea, when we was one big continent, broke apart 200 million years ago. 200 million years ago. So now it looks like this. Well, if you really put the pieces together, we look about right. We kind of just spread it apart. So it says that we drifted. Continents broke through the ocean. So if you look at the different ones, there's different periods to how we are now, but it was basically stated that we always one. And again, that's called Pangea, but it's actually under Wegener's theory. Now, how do we know this even happened? Like, we're hearing he say, she say stuff and what Miss Cheek just said, but how is it really true? Well, the shorelines look like they fit together. Okay? So, shorelines. We have found fossils. Fossil is the remains of something that was once living, found that are the same on different land masses. We had several mountains that end at one coastline and reappear at the other. So it looks like it was just pulled apart because the height and the mass is all the same, as well as the climates add up together. So here are four things: the shorelines, the fossils, the mountain belts, and the climates. So this whole theory of plate tectonics. So what is this? Well, it proposes that the Earth's outer shell, again, which we live on, consists of plates. That's what we just talked about, right? The convection currents and stuff move these plates. And so they cause earthquakes, they cause volcanoes, mountains, and the crust itself. So when the plates move, of course, that gives us like an earthquake. And if the plates collide, it probably giving us a volcano or something, right? Or the mountains. So we have these things that we have to look at. So, what are our major plates here on Earth? Well, the lithosphere floats and moves along the mountain. So, we have the top seven plates. We have the African plate, the Antarctic plate, the Eurasian plate, the Australian Indian plate, the North American plate, the Pacific plate, and the South American plate. Now, what's left? We have the Arabian, the Caribbean, the Cocos, the Nazca, the Philippine, and Scotia. We have these plates that are remaining, but these are our top seven. Where are we? We're North America, right? So we would have did this if you was inside the classroom, but I want you to actually look and see what takes place here. Um, we have different types of plate boundaries. And what happens there, we get earthquakes, we get volcanoes, we get mountains, and we get sea force spreading. So now we're going to know how we have to identify about what type of plate boundaries. Well, let's go back to Pangea first. Occurred over 500 million years ago that we was all together. Continents broke up at least 200 million years ago. North America split about 13. Okay, so none of us lived that long. Okay, so we really don't fully know, but by looking at this is a theory, so it has not been proven wrong yet. So let's talk about our first boundary about maybe how this all took place. Well, we have divergent boundaries. When I hear divergent, I look at this word right here. Divergent, divide. Okay? Divergent, divide. So this is when it also spreads. So once it spreads, what comes up? So what does this make? What does that look like? Look like a volcano, huh? So when two plates move apart, so divergent, divide. So this is my little symbol to show you dividing. Creates a seafloor. So how do seafloors come? Well, right here. So seafloor spreading causes ocean ridges. Okay. So this is O and O is going to be the ocean. The continental is rift valleys. So ocean is oceanic crust and oceanic crust. This is continental and continental. This is rift valleys. So divergent, we have the lithosphere. We have here, look at that, magma coming up, right? So again, divergent, divide. So the two oceanic, this is where tectonic plates or oceanic features gives you a mid-ocean ridge with a rift split down the center of the undersea mountain range. So you can get earthquakes or volcanoes. You usually don't see volcanoes unless it's near, honestly, a lot of ocean. So this is your mid-Atlantic ridge. This is your example. You have to know the effects. You have to know the example. Okay. Continental to continental. So this is where the continental crust comes and gives you rift, volcanic mountains. Okay. So now this is where we get the volcanic mountains that are not there because it's continental, continental. So this is going to be shallow focus on the earthquakes volcano activity, but our biggest example is the Eastern African Rift. Convergent boundaries. So if divergent means divide, convergent means collide. Okay, so this is where two plates move together. So oceanic, continental. So you have to know these different terms. So oceanic and continental. So O and C boundaries. Oceanic plate goes beneath the continental plate. All right. So here's an oceanic and here's the continental. It goes under. All right. This causes subduction zones, trenches, and continental volcanic arcs. Continental, continental. So this is CC. Makes two collide. So continental, continental, and we get mountains, right? Oceanic, oceanic. When that happens, this will make one go under the other. So our oceanic plates begin to go under another oceanic plate. This creates volcanic island arcs. So what is some more information about convergent? Well, I try to simplify it. So convergent, continental, continental. So again, large mountains if continental, continental. Strong earthquakes, not really no volcanoes. Big examples is the Himalayas. Well, what about oceanic continental? Well, this is going to be deep trench, parallel volcanic mountain ranges. A lot of times is earthquake activity. Okay. The big one example for that is the Andes Mountains or the Cascade Mountains. Oceanic, oceanic. So where tectonic plates are basically now the oceanic crust. The features here is a deep ocean trench, volcanic island arch. So we have deep earthquake activity, subduction of the oceanic plate, which can cause explosive volcanoes. Now, if these two convergent, so they collide, and you're talking about explosive, so this one gives us explosive as well. But this one is definitely explosive. Philippines has a big volcano, right? Japan has one. Alaska has one. So if divergent divides, convergent collides, transform, it slides against each other. So this right here, San Andreas Fault is one of the biggest ones. So transform, basically earthquakes, um, very intensive earthquakes, San Andreas fault, Apollon fault. So here's a quick way to make sure you remember it. Divergent, divide, tectonic plates move away from each other. Convergent, collide, plates move together. Transform, we slide. So every time we have an earthquake, that's when plates are sliding. That's friction, right? You slide something, you're gonna hear the friction. When you're playing sports and stuff, and you got grip on your shoes, you have the friction. The tires is friction on the road. If you run into something, if two cars had a head-on collision, does the cars go just flat, or sometimes it kind of goes up? Kind of goes up. If one person pulls one part of the car and the person pulls the other side of the car, it splits in half, right? So that's basically divergent, convergent, and transform. So we need to have some real world examples. This will pop up on your test. But convergent, we have the Nazca plate and the South American plate. Divergent, Mid-Atlantic ridge. Transform, North America and Pacific plates are sliding past one another. And so again, San Andreas fault here, the Mid-Atlantic ridge picture here, and then as you see, the plates are moving towards each other right here. So again, how else do we know that this plate tectonics did? Well, the paleomagnetism. So this is basically the magnets that are acquired by rock that can be used to determine the location of the magnetic poles. Okay. So then we have earthquake patterns. We usually don't get earthquakes here, but we do have a fault line. So we just had an earthquake here not too long ago. So that's going to be one of our studies. Ocean drilling. Younger oceanic crust is at the ridge crest, and the oldest is at the continental margins. Hot spots support the plates that move all over the Earth's surface. So again, what causes the plates to move? Well, we talked about it. It's in the asthenosphere, and it's the convection currents. And so that keeps it from basically driving the force of plate movement. As you see, we got some going clockwise, we got some going counterclockwise, and then we got some going down and eventually come back around. So what happens is a total, as you see, slab and pool. It's continuously moving. So now when that happens, though, we have three types of stresses. So three types of stresses among rocks. We have tension. So if you was being pulled and stretched over a period of time in opposite direction, you're eventually going to have tension, right? What happens to your muscle when you get a tension muscle problem? It's been pulled too much in different directions, and it causes tension. What about the compression? Well, compression is just like this. It's just being squeezed. If you keep squeezing a soda, or you keep squeezing a bump, or you keep squeezing something, it's eventually going to be distorted. Or even a can. If you squeeze a can, it no longer looks like a perfect little can. When you squeeze a can, it comes like this. It loses its shape. It's being squeezed. So basically, that's compressed. Okay, shear causes the material to be distorted but not changed in volume. So now, if after we know about the stresses, well, what about the folds? What happens? Like, we have rocks that go high, we got rocks that go low, we got mountains, and we got hills and valleys. Well, we have to know the types of folds. We have anticlines. Okay, so anticlines, upward folds. Okay, synclines, down folds or through basins. So as you see, down. Mono is like a step. So you see how it kind of go like this. So anti, up, sync, down, mono, step. So up, down, step. So what are the faults? So I've been talking about that San Andreas fault line, right? Well, faults are formed when it's a crack in the rock. Boom, crack in the rock. if you eventually have a crack, what's it going to do? It's going to have a reaction, right? So we have the hanging wall. So the rock above the fault line and the foot wall. So you see that there's a gap here. So that makes it kind of like a step type thing. So we have the hanging wall. That wall hangs over the foot. And as well as we can have it reverse. So we have normal or we have reverse. So look at the normal. The foot wall right here and the hanging. And then you have the reverse fault, which is weird looking, right? And then it says right here, an earthquake, so it can just change it to fall. That's why if you ever notice like an earthquake, some lands the ground breaks and then the land gets lower on one side and sometimes it just splits apart. So then we have the thrust. So the thrust is the reverse fault with dips of less than 45 degrees. So this is when when the earthquake happens, sometimes we do see like the different levels go like this in the ground, and that's not fake. It's strike slip is when it goes the horizontal. So like if you're doing a match, this is like a match, okay? Boom, you're trying to get it. It definitely shifted everything, okay?